thanks as well, Professor Jarbas Bonetti, for your time.
Agora sim, tá valendo.
For your time and be available at this time of the year to do the evaluation of Mariane dissertation. Okay, thank you very much for you, Professor Bonetti, and for you, Professor Giovanni. And Mariane will have 30 minutes to do her presentation. And then the next step is going to be the evaluation, and you have time to do questions and ask for modification or improve the dissertation. Each of one will have 30 minutes for the evaluation, do questions. It's for her, not for me. It's her defense. And then we have a meeting together, I, Professor Bonetti, and Professor Giovanni Coco, to discuss the grade. We have to give a grade between 0 and 10, and say that it's proved or no the dissertation. This is the how will be the defense. Okay. Any question? You just ask us, Professor Giovanni. Okay. And yeah, Mariane, it's your time. 10 minutes from now.
Okay. Thank you, Professor Klein. During the next 30 minutes, I am presenting my master thesis entitled Morphological Evolution of the BABITONGA Bainless, Santa Catarina. First, I'm going to contact the subject, then tell about my motivations, the main goals, characterize the region, the material methods utilized, the results, the conceptual model elaborated on the results, and finally the conclusion. So, first, mesoscale inlets are usually associated to large tidal prism. That's because the tidal prism can be somewhat described related to the surface area of the associated body water and the tidal range. Even that tidal inlets with such size is usually associated with tide-dominant coasts, we also can find them along wave-dominant coasts. That's because they usually depict such large surface area. When you have such size of inlet, they will also depict a large inlet throat cross-sectional area. That's because the volume of water that enters the bay and leaves during a tidal cycle needs a large cross-sectional area to be pushed into and out of the bay. So this kind of inlets, they depict usually large sand bodies, which are the deltas. That's because they are related with those aspects that I just said. But the tidal currents and tidal range, they play a key role in distributing those sand deposits. More than that, the wave energy is important, the long-short transfers, and the fluvial discharge to the distribution of those kind of deposits. So first, I'm telling now about the role of waves and tides in generating the transport along those kind of inlets. First, we have the waves showing a break on the front of the delta and creating a landward directed transport, which means that the sediment is being pushed towards the entrance of the inlet. On the other hand, we also have the waves coming obliquely from to the coast and then creating a wave-induced current that induces long-short transfers in the along direction of the delta, and then the sediment can be transported along the outer delta. The tide also play a key role mainly in skirting the channel of the inlet, and then pushing the sediment along the channel flank. Since in this example, the waves are not strong enough to push the sediment to the coast, so the sediment stays accumulated in the form of linear bars along the channel flanks. Well, when you have a mixed energy environment, you have those two drivers generated transport along tidal regions. So we have the waves formation those bars along the spatial waterfall, and you have we have the tides inducing a suspended motion with the waves, mostly during fluid conditions, that ended up creating a landward transport along the marginal channels of the inlet. When you add a rock boundary along a coast, this means that several mechanisms of bypassing is created. The existing models of headland bypassing, four models of headland bypassing we have so far are in here. We have first the slash surf zone model, in which the sediment trespass the headland by creating a bar attached to the shallow part of the coast, and then the waves contributes to its motion around the headland. We have this alternative model in which the sediment is pushed seaward of the surf zone, but still within the closer depth, in which we have the formation of recurrent speech and a recurrent that contributed with the transport of the land shark current. This will trespass the headland. And finally, we have the cross-embayment model, in which the sediment is pushed to even deeper portions of the coast, and as by the waves, the wave-induced currents, it is pushed through along the downdrift beach until it reaches the other side of the island. So, why studying bypassing along a headland-controlled mesoscale inlet? The mechanisms of bypassing along inlets have been described by Couceiro collaborators, and there are several studies that assess those sedimentary processes along those kind of inlets on inlets spread across the globe. Nevertheless, there is a scientific gap in sediment connectivity and its dynamics along rock-bounded inlets, because the presence of a rock-bounded adds complexity on the inlet bypassing model. So, because of that, the main goal of the study is first investigate the change in morphology in BABITONGA inlet over 160 years, and then describe the influence of those features' evolution on an associated headland inlet bypass. For that, we elaborate a conceptual model of headland and inlets associated bypassing process. Now, describing the area, the BABITONGA inlet coast is a microtidal east-west dominated headland bay coast. It is dominated by wave, still dominated by wave, but has a mixed energy as Davis and Hayes classification. The mangroves and large tidal flats that comprise the bay contribute to the amplification of the shallow water constituents of the tidal wave. This means that the wave serves as an amplification when entering the bay, and then to solve this asymmetry, the BABITONGA Bay presents stronger eddy currents in comparison to flood currents. About the morphology, we have the BABITONGA inlet being bounded by a beach reef ramp on its northwest side, and São Francisco do Sul Island rock basement on its southwest side. The channel depicts cross-sectional asymmetry being deeper on its northwest side. That's because of the stronger flux and flux that I just explained. The epicadal delta depicts an asymmetric contour due to the shelter of the São Francisco do Sul Island. On recent decades, during the 80s, dredge intervention deepened the salting lobe and connected the flood channel with the epitidal channel. More than that, we have a flood tidal delta on the southeast side of the inlet. The sedimentary pathways involved on the transport along the BABITONGA inlet can be explained related to the beach systems along the coast. First, the sediment accumulates along Enseada-Ubatuba beach system, and then during high energy south waves, the sediment is pushed toward the inlet's mouth, the inlet's entrance, and then east waves play a role in redirecting this sediment toward the channel. More than that, when in the inlet's mouth, the channel can take an alternative pathway and be directed to the north lobe directly. Then, in Tapua Beach, it can be again redirected to the channel and then again to the epitidal delta, or comprise the flood tidal delta, or extend the Capus Beach. For this work, we utilized nautical charts, board sheets, and recently surveyed bathymetric data set. The nautical charts and board sheets were made available by the Brazilian National Digital Library, the Oceanographic Brazilian Database, the Academic Corporation, and this work is just possible because of the RESPORT and Big Speed projects. We gathered this bathymetric collection of 160 years, and then we georeferenced and digitized those historic documents, which result in 200,000 samples. Then each dataset was fit to a semi-program model in order to select the interpolation parameters, searching direction, like size, number of beams, and searching radius. Those parameters were very important to apply into different models, 3 different models, which were compared, the results were compared, in order to establish the best fitted model to represent the morphological features of BABITONGA Bay. So the inverse distance weighting was tested, the ordinary kriging with trend removal was tested, and also the empirical Bayesian kriging. Those methods were compared and evaluated using a cross-validation method. The method that presents the best fit for the bathymetry of BABITONGA inlet was the EBK method. The EBK method presents an accuracy of 0.1 to 1.5 meters. Then the digital elevation models were generated using a 50-meter cell size. The digital elevation models were compared using the aspects of depth, the slope of the terrain, and the channel geometry, which means the distance between the center line and the most extent boundary of the channel, which was used the 10 meters boundary. So the results. First, this first period, 8 years. So here we have the Itapuá coast, and then we have São Francisco do Sul Island, and then here we have the depth. So the red portions means that the shallow part of the inlet, and the dark blue portions mean the deepest part of the inlet. So here we observe that this southern channel alignment that we observed were substituted and changed to an interspaced deeper and shallower zones. That was accompanied by the development of an epitidal delta asymmetry, which means that in this bathymetry, the sand was being pushed farther from the inlet entrance and accumulating on the beach. And now the sand is depositing in the middle part of the epitidal delta on its northern lobe. This led to the intertidal zone formation that we observed at the end of the period. During this period, we can say that those interspecies different shallow zone was caused by the accumulation of those mid-channel deposits. Those mid-channel deposits most cause the channel to meander northward. That's because they shallow this part of the channel, and then it created a cross-sectional asymmetry. This leads to the lateral migration of the channel. More than that, on the northern lobe, the channel encounters no resistance in comparison to the rock basement of São Francisco do Sul Islands, and then it can score the northern bank. Those are the isolated deposits, represent the isolated deposits along the channel. So, the second period, 30 years of analysis, we have those deeper and shallow sections of the channel being again substituted by a probably abyss-dominated channel at the northwest band. This created an asymmetric deepening, which means that this band was much more square than the other one. More than that, we have the development of the Galerada intertidal complex, and most because we believe the epitidal delta entered in a trapping phase, which means that while this intertidal complex develops, we have the refraction of waves increase along this area. Furthermore, we have a south graduate being created, and the delta keeps pushing and capturing the sediment from the long-shore transfer. It leads to the creation of an offset and asymmetry of the northern lobe that starts to overlap even more the southern lobe and created a spit directly to the updrift side of the inlet. During this period, we believe the intertidal complex, as I just explained, played a key role in creating a new geometry and established mid-channel deposits on the inlet's mouth. That's because while the intertidal complex expanded, the inlet's mouth impinged against the southern lobe, and this creates a secondary flux that leads to the formation of an inner band deposit, which means that while the channel bends, it skirts the one side of the band and deposit channel on the inner band, on the inner curve accumulation. This probably led to the enhancement of the currents. Here is a representation of this mid-channel deposit and the updrift scurry that led to a northward alignment, to an updrift alignment of the inlet's mouth during this period. This geometry at the inlet's mouth with this mid-channel deposit in the inner band that I just explained became constant along the 50 years beyond that period. That's because the updrift bank remains to be stirred on its landward part, and the Galerada bar keeps expanding during the next 20 years. More than that, during this period, we had a general loss, vertical loss, along the epitidal delta, as you can see here in orange. And we also had the deepening of the dredge of the shipping channel, as I explained. This channel remains until nowadays, where what they did was to connect the fluid channel, which means the deepest part of the southern lobe, to the main ebb channel. So here we can say that this geometry at the inlet's mouth remained from the 70s to the 90s decades. So we had this board sheet from the 80s, and it played the key role in enhancing the resolution of the analysis and becoming a decadal analysis during this period. That's because the channel alignment on the upper drift direction and the cross-sectional asymmetry due to the northeast bank scurry were very important. With that, we have the dredging that connects both channels that will play the role in funneling the tidal wave, which means that when the tidal wave approximates the coast, this deeper and narrow channel play a role in enhancing the tidal current. So we believe it happened was that here we had in the 70s a flood channel around the headland, and then we have the dredged channel that we believe now is playing the role of an ebb channel, while the secondary channel formates to be the flood-dominated channel. More than that, we believe this process expands the reach of the outflow, while the outflows created more connections on the southern lobe due to the deepening. So, this secondary flood channel that I showed in the last picture, and those vertical accretion points in blue in this picture, we can say that this contributed to the transport from the headland toward the inlet's mouth. During the next decade, we see that actually that the Galharada is expanding again. We believe that's because the segment that was trapped on the inlet's mouth now has reached the northern lobe of the Orientador Delta. More than that, we believe this mechanism is happening because during this period, due to this deepening of the bank, which is an evidence that the transport involved the big systems of Mestrado and Fort Pitch Cap speech, as I explained, are weakened due to the not participation of those kinds of transport of sedimentary pattern. So we believe that now we have the other mechanism of sedimentary bypassing, which is the sediment accumulated around the headland, and then it is transferred along the terminal lobe, since since waves can transport them on the along channel direction in the Orientador Delta. During the next decades, which are the recent decades, this geometry at the inlet's mouth still remains stable. The cross section has not changed its width, and then the certain lobe start to be scoured by, we believe, by the ebb flood. More than that, we observe the sediment retention along the southern band, and which indicates that the sediment pathway toward the channel is now favored, and now it's occurring, which means a shift of the sediment bypassing mechanism. More than that, Galharada Bar started again to retreat, and the channel was deepened to the 40 meters depth. So, I put this figure in here so we can discuss so I can present, and then I will discuss the behavior of the Orientador Delta along the 160 years. So first, we have the sediment being pushed to the beach, farther from the inlet entrance. At this point, we still have this southern alignment, this updrift alignment. Then we have the sediment again being pushed to the inlet's mouth. And then we have this phase of Orientador Delta sand trapping, in which the sediment is capturing the long-term, the sediment from the long-term transport. So we observe that the bathymetry from most recent data sets looks very alike with the earliest one, and we believe that's because this indicates a cyclical pattern of the Orientador Delta accompanied by an anti-clockwise rotation of the alternate channel. is the conceptual model for associated process of headland and inlet bypassing that was elaborated from the results of the morphological analysis. So, what we see here is that during this first phase, we have the channel with a downdrift alignment. One may expect that this downdrift alignment of the ebb flux result in the dominance of the fluid flux along the portions around the headland. This most likely contributed to the formation of the mid-channel deposits we observed on the morphological analysis and the cross-section asymmetry that led this side of the channel to be shallower than the other side. This means that during this side, the ebb flux can intensify since it's more deeper. More than that, if the outflux is intensifying, we have the deposits, the epithalodontal deposits, expanding beyond the rock boundary, which means they can depict a freeform. They can depict a freeform in terms of the outline of the channel. This process that I just explained most likely have to enhance the ebb jet, which means this recirculation cell here in the north lobe is enhanced and then capturing sediment from a long-short transfer. This means that there is a reserve of sediment being supplied in the northern lobe. This led to the formation of the intertidal complex and the development of this speeds of the drift directed. It's likely that when it happens, we have the ebb flux being redirected in the direction parallel of this speed. This created an hydraulic inefficiency that is solved by creating an updrift directed branch, and then the outflow can be directed to the headland. So when we have this outflow dominance around the headland, this prevents the sediment that trespass the headland, as in the model of bypassing I explained, to enter the channel. Then the sediment stays in here until it is reworked by waves and migrate through the outer shoals. To sum up, we have those two main goals, which were to investigate the chance in morphology over 160 years in BABITONGA Bay Inlet, and to describe the influence of those features evolution on associated headland inlet bypassing. We did this compilation that results in a long-term morphological database that allow us to reconstruct the features evolution on BABITONGA Inlet and elaborated the conceptual model for associated headland inlet bypassing that was proposed in addressing a rock-controlled mixed energy tidal inlet. That's it. I appreciate your presence in here today, and I would like to thank you, all of you guys. Thank you.
Okay. After the presentation of Mariane, we gonna move to the next step. It's gonna be the evaluation. Okay.
Okay.
As normally, Professor Giovanni, we invite the professor that are far away from our university. I think you are far away enough.
I think I win.
To be the first. Okay? It's your time now.
Okay, so first of all, I want to congratulate Mariane for really very good piece of work, very interesting research. I think you have made incredible good use of the data you had. I really enjoyed to see how you prepared the data. It's clear that all data was coming from very different sampling was in very different times, so there were difficulties there, and it's always difficult to understand what happens in those environments, in those tidal inlets. They are some of the most extremely complicated environments. So I read your thesis, which I actually found also very well written. Congratulations for that too, and congratulations also to your advisor, clearly, for this piece of work. And I think the work is incredibly interesting, and what happens with interesting work is that I end up having questions that are not so much about what you have done, because what you have done is very clear, and also today you presented it very well. I really liked the sequence and the difference in erosion, accretion that you were explaining. But I have more general questions. For example, for a system like this, you have to also forgive my ignorance about the system itself. I wish I could go and see it, but I'm a little bit far away. So I will ask you also some more general question. In your thesis, for example, you explain that waves might be undergoing some changes over time, and this might also affect the morphodynamics of the inlet. With respect to this, I wanted to ask if you could be a bit more specific about the type of changes that are occurring, are in height, in period, and also what about major storm? Is this a coastline that is affected by major storm? And do you think major storm and so waves, increased setup, storm surge, could they affect, could there be a single event that strongly affects the morphodynamics of the inlet?
Thank you for the question. Regarding the waves, during the attacks, I see that the waves are changing on the southern Brazil, mostly because of it's getting bigger. And then I say that during south waves condition, that here in southern Brazil, we have the cold fronts that enhance the height of the waves. So during these conditions, I see that it would be likely that the credit channel, like in the southern lobe, would have a bigger role in amplifying the tidal range and the tidal wave, and then the tidal range, and then the tidal currents. So in terms of the response of the dredging, I think that is the major result of a higher energy climbing. But in terms of waves, in terms of the morphodynamic of the estuary, I think that when you have higher waves, you have more waves to rework the sediment that's trapped along the outer bars. So I believe this protection of the coast at this point, which is the outer bars and the ebb shoals, will be like reduced.
Okay, that's great. That's an answer I really like. I enjoy seeing that you have really thought out the system works. So let's go a little bit wilder with questions. What do you think will happen to the system when sea level rise really kicks in? At the moment, yes, it's increasing, but slowly, but we predict it will accelerate. What type of changes do you predict? Can you predict?
Okay, thank you for the question. Babitonga Bay is a very urbanized bay. So I believe those changes in the level of the sea, most sea level rise, it would enhance the accommodation space of the bay, but it would not enhance the width of the bay, that the environment could expand it laterally. Because of the urbanization, it would constrain this sea level rise, and then it would enhance like on one dimension, like just in one direction, like up and not laterally. And I believe this could like decrease the roughness of the seabed. That's because during this phase, the tidal currents that enters in a normal situation, they are like dealing with the mangrove. But then in a sea level rise situation, they will deal with the upper portion of the mangrove, which are the stems of the mangrove trees. So it will change the rootness of the seabed.
Okay, so there will be differences in tidal propagation, you're saying. So maybe there will also be some difference in the dominance of ebb, flood. So maybe something like that could also happen. Which brings to another question. Those type of inlets, they tend to have, or at least a lot of these type of inlets that I've seen that have such interesting behavior, there is almost some cycle that tends to be repeated. What do you think about those cycles within the context of the Babitonga Bay Inlet? Is it possible to think, like, let's imagine there is no sea level rise, but what are the future stages? You are probably one of the person that knows most about these inlets. So what do you think will happen in the future?
Yeah, when I first started to read about the subject, I came across the Elias doctoral thesis. And one thing that caught my attention is that he says that the updrift directed of the inlet's mouth is something that cyclically occurred along the Texel Inlet on the Netherlands. So I think this is a good example, and adding up my conclusions on Babitonga Bay, that this kind of cycle is normal, and on climate change conditions, it could change quickly. For example, when you have this updrift directed change, we have the bypassing mechanism being affected by that. So we could say that the change on sediment transport will be very faster than the normal conditions.
Okay, nice. Another question. What do you think would be the correct sampling frequency for the bathymetry to fully understand what goes on? You dealt with whatever you had, you did the best possible work. How often should this inlet be sampled, the bathymetry collected? Every 5 years, every 10 years?
Yeah, what I saw is that even when we add the 80s board sheet that allow us to enhance the resolution of the analysis, we saw different things like the galerada bars cyclically expanding and retreating, and those sedimentary points on the inlet's mouth and then around the headland. So I would say that even less than 10 years, like 5 years, that we could like investigate the decadal process that occurs on the Babitonga Inlet. But more than that, we could investigate how those decadal processes are influenced by the major process of morphological, long-term morphological evolution.
Okay, now I have my final question. I will give you $1 million US to do research on this inlet. How would you use the money?
First, I would do survey the region, of course. That's because I believe we don't have the knowledge about the inlet's response to the dredging, because it's very recent actually. So the long-term inlet response to the dredging, we don't have it. And then more than that, to know how the short range features, such as the seabed waves marks, bottom marks, how they can say to us how the sedimentary transport is changed in a decadal scale or such. So I believe I would enhance the surveying campaigns along the Babitonga Bay and study better the bed marks of the area, and then proceeding on runs process-based models that could say that if the morphology is responding to a change of tidal symmetry. So I believe I will go further during this type of questions.
And this is the best answer, both field and modeling. I think that's also always what is needed. Thank you very much. It has been a pleasure to read your thesis and attend the presentation. Also thanks for the answer to the questions.
Thank you.
Okay. Thank you very much, Professor Giovanni, for your smart questions. Now, we will move to the Professor Bonetti. Now is his time to do the evaluation. Come here, please. It's cold here.
Ok. Boa tarde. Buongiorno, Giovanni. Piacere di essere qui con te.
Buongiorno.
Well, so I'd like to begin by thanking you all, your supervisor and you for inviting me to be here. Just putting some consideration about your work. As you know, we discussed this before in your qualifying. This is a subject that I'm very attracted to. In fact, it was my first geomorphological research in my master thesis many years ago. The study of American delta and this kind of complex. So this is an interesting subject, something that I really like to learn and to see the development of research on that. And also the area you chose was a very interesting one. I had some contact with the BABITONGA area. So I was very happy to read your research and also to learn from your accomplishments and the data that you just arrived to process. So as a more academic point of view, I'd like to begin saying that it's a very well dimensioned thesis. You choose a length of things to process and to write, which is quite acceptable for a master thesis. The structure is very efficient. This new model, new for us here in Brazil, that we're adopting the last maybe 5 or 8 years of having a paper related to the thesis of introduction and then some considerations is very effective, I think, because giving to the students the opportunity to produce something that would be more widespread through the audiences. It's not just an inner product that you go to the library and stay there without not many people seeing all your efforts and taking advantage of your research. So it was very good, and moreover, you arrived to a very concrete proposition, which is this model of sediment transport around this kind of features in a special setting where we have this headland. So you arrived to something really real, which is not very common and it's very mature. Very good to see in a master thesis. So congratulations for you and for your supervisor and your post-supervisor that is not here, but just remembering that also was involved with this research. So this is all very good. And about these models that you proposed, I'd like to begin questioning about this. You showed some possibilities because you compare different time frames, different dates, and see that you saw that things changed, the features moving, and then you propose that something happened to condition that movement. And I'd like to go back to one question. I think Giovanni touched this point because you have some instant pictures, which are the bathymetric surface, and sometimes from one to the other you have some decades that pass. So my first question is: do you consider that this evolution that you proposed is linear from the 19th century up to the last one? These steps were followed by the geomorphological processes, or you consider that it's possible that between dates you had a turnover or just a loop that came back to a previous condition, then it just went to another, like we do in beach profiling. When we study beaches, sometimes you see different things, but between the two dates you have a lot of things that have related to stones, for example. So what do you think? It's linear, or we have this cyclical?
I think the features went through those cyclical chains during the same period, while the same period that I studied. So, for example, we have during the first 8 years, we have Galharada bar creating those intertidal complexes. But I don't believe this happened this way that is depicted, like two bathymetries and two static pictures. I believe that, of course, it went through cycles of retreat and expansions. But I believe in the long term, we have this result, which means a lot, especially in terms of the geometry of the channel in the long term. So we see this feature changing and shifting the channel, the main channel, and so the alternate channel in the long term.
Okay. I was silly enough to write my notes in Portuguese. I didn't realize that it would be in English, so I must to interpret what I'm writing here and to show you. So, okay, so you made this very interesting research paper that you submitted already to Título Morfology, I understood. Yeah, and of course you have different co-authors that are specialists in various aspects of your research. So I'm not going to the scientific quality of research, which is very good. I'll just point out some aspects that I think could be a matter of consideration for you. For example, you decided to investigate an interesting and complex feature, which is the tidal delta systems. And from the geomorphology, from its form, you proposed your sediment transport model. But I missed in your research some consideration about the sediment types you have in the area. So as far as I could see, you didn't mention what are the sedimentary matrix of the area. You have more mud, more clay, or it's a sandy, or coarse sand, or whatever. So, and you have data in the literature about all that. So I think also you should have to be interesting to consider the types of segments you have there. And about this, when you propose your models, you didn't mention that during this 100 and many years from the beginning to now, we had a very important change in the sediment supply from the watersheds. So we had forestation, urbanization, agriculture development, development of portuary infrastructure that moved everything inside the bay. So don't you think it would be an element to be added to your model, eventual changes in sediment supply, not from the sea necessarily, from waves, but from the linear portion of your area?
Sure, yeah. We have this classical word. I can't remember the year, but the author. But it says that there's a very important change in the watersheds, most on the side of southern coast of the Brazil, related to the accumulation of sediment along the draining. How can I don't know how to say in English the portion that they stop the floods. So we have to consider the draining of this kind of sediment that will change the type of sediment.
Okay.
But here I don't think how I could do that in the research. I can.
No, I'm not talking about you, but something that could be put as one of the possible inputs or triggers of this development.
Sure. Yeah. The region that we focused was that the inlet entrance sand dominated. But yeah, we have along the bay, we have this type sediment changing the entire bay along the bay. We have tidal flats, we have mud flats.
Mm-hmm. Okay, and since you use this geomorphology to estimate transport, I was expecting at the end of the research that you make a more directed dialogue with this research that you mentioned many times from Silveira and collaborators, because it's a model of fluxes or transports that was developed based on numerical modeling. Which it's not what you've done, it's not a problem.
Yeah.
But I didn't see this connection.
Cooperation.
Yeah, so did the model that Silveira proposed states that this kind of thing will be happening. My features say that maybe yes, maybe not. So how do you compare both? How close? It's in your first figure of the
Yeah.
How do you compare the model, and what was the situation of the model, the morphological situation of that?
Sure.
And your
Yeah. The model proposed by Silveira, based on process-based models. I didn't perform this comparison. That's because my goal was to create a sediment transport model for each phase. So I could say that the transport is changed, but if I think that how I could compare it to the Silveira model, I would say that actually Silveira model explains very well the features we see today. Mm-hmm. So since it was run with nowadays features outlined, okay. So I think we would explain very well the features, the morphology of the features as we see in BABITONGA today.
Yeah, maybe when we receive some feedback from the reviewers of the article, you may add one sentence just saying that there is a research using physical modeling, numerical modeling, and this just relates to.
I was worried during the writing part to not compare the model with other conceptual models around the world, because our intention was to expand this case study beyond and compare with other conceptual models for other morphological analysis of inlet spread deposit growth. So I compared with some conceptual models from other
areas.
Yeah.
I'm going to arrive to this problem.
Okay.
All right, but okay, good. So concerning the methodology, we discussed it a lot during our qualifying, the interpolation techniques, errors, and possibilities. So I won't go back. You made your choice, which is a very good one, and it's well described here. But I have the feeling that your concern about the choose of the best interpolation technique still is too big in this research paper, which is much more related to processes than to this technique. So if you take a look in your flow chart that is in the paper, you will see that all the flow chart is only related to the interpolation and validation of the bathymetric data. All arrows arrive to the MDTs. You prefer to use DEM after digital terrain model for this. But anyway, so you didn't. This is in fact not the methodology of the whole paper. It's the methodology of the interpolation or the MDT generation, because you don't put in this flow chart things like slope or map algebra to subtract one date from the other date. So maybe you should revise this flow chart to be more wide, more abundant, to take all the research, not only one of the aspects of research. And I should confess that I was a little bit frustrated with the small amount of image that you presented in your thesis. Here you showed a lot of very beautiful things. These pseudo 3D models, and also the digital terrain models, because this is I think the most of the methodology discussions about how to generate this MDT, this EM. And you showed a simplified version of the geomorphology, but it's beautiful one with a lot of colors with the continual gradients that you showed here. Is not present nor even in the annex. So if someone would like to check in more detail where is the frontal lobe, where is the marginal channel, where is the sandbar, it's not here. You only presented a simplified version. You understand what I'm saying? There's a picture there when you just yes, you showed you showed there in the paper, perfect, the simplified one. But if you go back to different entities, go back. No, back. Again, probably one of the first ones. Okay, so you see this on the other side. You don't see that in the paper. And this is the raw data that allow us to identify features. As you didn't show the slope map. You mentioned a lot the slope, but you don't have this picture.
Yeah.
So think about putting this in the annex or only for someone that they just check. Okay, so this, you can see it's very interesting, the position of the lobe or whatever. So it will give much more visibility to your research. It's kind of not validate, but give some street sight for the reader to follow your thought, because it's a very descriptive work. Sometimes it's hard to try to understand all the relations that you made when you describe the changes between one to other days. And when you have pictures and have figures, it helps a lot to follow your thoughts.
Maybe label on the interpolated surface. Label the interpolated
surface. Yes, something like that. Yeah. Okay, another thing that I think I told you that in your qualifying, and that's very important when you're comparing different interpolated surfaces, is to give some background data to the reader. For example, we don't know the geometry of the sampling points of each one of the nautical charts of the Pullig's board. And we don't know the spacing between the points in each one of them. Of course, you interpolate at the end, you made a regular read with meters, I think. But the first nautical chart from 18-something has the same extent, covers the area as all the others, or it covers only one part. The north is present there, or they didn't sample the north. The number of points you have in this nautical chart and geometry, the distribution is the same to the one from another data. So sometimes you may be interpreting some features, not because they exist, but because you have an original data with an extent, a density, and a geometry that gives this false features. So it doesn't put a problem to your work, but again, when you show this nautical chart, this data has this geometry, this extent, this density. Someone can say, okay, so this is different for this one. Maybe also because they didn't cover the southern part, or the back soundings are very spaced here, and it was made a certain align the channel and not, helping to understand the transversal distribution of bathymetry and so on. So it's the background data that again gives more value to your work, and you think about putting this in the final version of this.
I already have this figure, and I'm certainly put it in the explanatory material. Like as you saw, there are like extra information.
Yes, which are very important.
Yes, so I'm certainly put it.
Okay. Whatever. Yeah, I think this is the core of my contribution, but I have some final questions to put here. So one of the very important, probably most important part of your research paper is this comparison. You mentioned this comparison to the previous conceptual models, and you say that BABITONGA net results in bypassing. You're saying this. results in bypassing mechanisms differ from those described earlier. And these other are the papers recited from Oregon and Price Inlet. So it's very, very important because this is this shows the scientific contribution to research. So you have something that people think that works one way, you're just putting another brick in this wall of knowledge and adding some extra information about the process of the feature or whatever. But I didn't understand so clearly what are the differences that you found from your work comparing to those two, for example, that you studied previously. So can you tell me briefly what is the novelty of your geomorphological system compared to the existing literature?
Sure, of course. Here in this figure, we can better see that. For the study of the Oregon inlet, for example, while the channel meanders and aligns itself with one of the bands, this part of the channel, it's like the central or landward part, as in my task, it's accompanied by this migration as well. In BABITONGA inlet, we have this outerman channel rotating, like doing that, and aligns itself with the upstream embankment, but the landward and sector portion does not respond to this behavior. I believe that's because we have this amazing coast with this large fluid tidal delta and the captive speech that extended up on the channel and created this northwest alignment in the center landward portion.
Okay, I see. And this has not been detected by these other authors, these other papers. So this is what I'm trying to push.
Yeah.
What you saw that they didn't see in there.
Yeah, it's the difference of the response of the picture depending on the along distance from the landward. Like depending on the section, the channel responded differently.
All right. Okay. Okay. And as Giovanni made with his classical question of giving you $1 million, it was $1 million, Giovanni. You're generous. I have some classical questions. First one. Well, what's the biggest problem? Not personal, not well, didn't have time or the computer broke, not things like that. But in terms of data methodology or data processing, what is the most difficult aspect that you face during the development of your research?
Yeah, to elaborate the conceptual model, I think the hard part was that. That's because I needed to study a lot about the wave row and the tidal current row on the inlets. So to have this in mind was difficult, especially because we proposed the flow direction, flow deflection zone that moves landward and seaward. So that was very difficult to me, but to propose this zone was effective because from that I could elaborate the model. So, but that was the hardest part. Harder than digitize it and referencing the historical documents.
Okay, and final question, another classical one. So if you were about to begin this same research from zero, what could you have been doing differently? So what are the choices that you made that you wouldn't made now, making this, if you come back in time and have the opportunity to develop this? What are the bad choices you've made?
Yeah, I think I would have separated some time frame to study the behavior of the Itapuá shoreline.
Okay.
But it's only possible since the 80s because of the satellite imagery from the 80s. But I think I would have to do that. Trying to explain the end of the cycle using the satellite imagery from the Itapuá coast.
All right, okay. Okay, Professor, thank you very much for your responses and congratulations for your research. And then we have this participation. So I'll give back the word to Klein.
Okay. Thank you very much, Professor Bonetti, for your deep and review and evaluation of the master dissertation, Mariane. Okay. Now we have to move to the next step. I will ask for everybody to go out of the room, and also Mariane. And Mariane, can you ask the manager to go to the transition, please? You can talk in Italy.
Italiano? Sì, parliamo in italiano.
Parla italiano.
Posso ci offrire un caffè?
Prego.
Ci dà un caffè? Caffè che è buono. Il caffè buono in Nuova Zelanda o...
Il caffè è buono a casa mia, non in Nuova Zelanda.
Sì. Ok.
I make good coffee, good espresso.
Sì, mi piace moltissimo il caffè, io vivo a base del caffè, la cosa più importante della vita, senza caffè non si fa niente, no? Ok,
Senza caffè non inizia la giornata.
But I can hear you.